Hi everyone, this is Pranav. Today we'll be looking at a problem called finding a path using recursion. So given the parent dictionary where the key represents the child and value represents the parent, your task is to find the path from the root node to the input child node, where the root node is defined as the child which has parent -1. So the given sample input can be seen over here and it has 1 as the root node because its corresponding value is -1, and the other entries are filled over here. I'll give you a diagrammatical representation of this particular dictionary present. So as you can see, I have represented the dictionary over here and the corresponding paths have been drawn over here. So if your test case says that the input child node is, let's say, 3 as given over there. So if our test case says input child node is 3, our job is to find the path from the root node which is 1. So 1 is our root node and our input child node is 3. So we have to find the path from 1 up till 3. So what we essentially need as our output is this particular path over here. So this will be our output. So we'll be returning this as a list 1, 5, 4, 3. So now we look at how we'll intend to achieve at this particular output. Okay, so now we'll be using recursion to solve this particular question. How we'll use recursion is as follows. So we have an input node 3. So we take 3 into consideration and look up its particular value in our dictionary. So for any key, if its value is -1, we know that it is the root node and we have to stop our function calls. If its value is not -1, then we know that it has another parent. So over here 3 is a child node, it has a parent 4. So what we have to do here is call the function using the parent node. So now our initial call was, let's say, path of 3. So our initial call was path of 3. Now we know that 3 is not the root. 3 has a parent 4. Now let us say 3 has been included in our path. So we know that 3 occurs in our path and we have included it. We know that 3 also has a parent 4. Now 4 can be included directly over here, but that would not solve our case because we don't know what comes before 4. So we are going to treat 4 as our new input child node and recursively call the path function in this particular call with the input child node 4. So 4 becomes our input child node now. So as you can see, 4 also has a value 5. That is, 4 does not have a parent of -1. So 4 has a parent 5. So we'll be recursively calling the function again using this particular input node as 5. So 4 goes into the path and we again recursively call the function path of 5. Again, it's the same case where 5 does not have a parent as -1. So 5 will again call the function and 5 gets appended to the list in the beginning. See, you have to observe one thing here is we append the elements in the reverse order. That is, the first element which called the function goes to the last. The next element comes as the second last. This is because we are finding the path from the root up to the input child node. So inherently it means that the input child node gets reserved the last position and our root appears in the first position. So path of 5 now recursively calls 1 again. So path of 1, and now 1 does not have any parent. 1 has -1 as its parent, which indicates that it is the root node and we have to stop our recursion. So you can observe that this function call over here is going to be our base case. So we'll end our recursion over here and throw this as our output. Now we'll look into the solution for this particular problem. We'll define a function find underscore path. Now this function will take as arguments parent dictionary and then our input child node and then a list L to store the path. So L here represents the list in which we are storing our path recursively. So anytime a function calls that particular node, that is, if let us say 3 calls this particular function, we add 3 to the end of the list. When 4 calls this particular function, we add 4 to the end of the list. That is what we observe. That is because we are finding the path from the root up to the child and the child reserves the last position. So we are going to make this happen. So whenever the function gets called, that particular node gets reserved the last but one element. Or let us say if our list has n elements before, the first position goes to this particular element over here. So we'll add the node to the starting of the list before proceeding. So our L will now be node plus L. So we want to add a node to the starting of the list. So we have to include node itself inside a list to append it to the beginning. So this will solve that particular issue. Now all we have to do is define the base case and the recursive call. So the base case happens when parent of node is -1, right? So we'll define the base case first. So if parent of node is double equal to -1, we know that that particular case is the base case, that is we have reached the root node. So we'll end our recursive calls and return the path L. Now if it is not the case, that is if parent of node is not -1, we observe that that particular node has a parent, so we'll call the function using that particular parent as the child. So we'll return find underscore path of, the parent dictionary remains the same, the node now changes to parent of node, and our path list also remains the same. So that will sum up our code for the function of find underscore path. Now we'll run a test case for this. So let me use the same test case provided over here. We'll define parent. Okay, I'll remove this. So our parent dictionary has been included. Now we'll input the child node as 3. So I think the child node is missing. We'll take input child node equals 3, and we'll make the recursive call and print the path. So print find underscore path of parent input child node, and to store the path we initially have an empty list, so we'll pass the empty list as another parameter. So we'll run the code right now and check if we get this particular output for input child node as 3. Yeah, as you can see, we get 1543 as the path from the root node 1 up to the input child node 3, which is same as the given sample output. Thank you.